Okay, so in this video, we'll be looking at another question where we try to design a regular expression that describes a language. So the language that we have here is the set of strings over the alphabet AB for which those strings, their number of A's is not equal to 2. Okay, so essentially, if I have a string W and L, then this is only possible if, for instance, its number of A's is 0, 1, not 2, 3, 4, and so on. So we sort of have to avoid when we create the regular expression, we have to avoid the regular expression describing any strings where the number of A's in those strings is exactly 2. Okay, so we want to avoid the number of A's is equal to 2, right? So, in cases like this, the the sort of simplest thing to do, I think, is to start with kind of like the base cases, the simplest cases, and then consider the more general case. So in this situation, in this kind of context, we have kind of the simple cases, which we can handle, and then the more general cases, or in this case, there's only one, so the more general case. So this is kind of just another regular expression creation strategy. When you sort of notice that there's kind of like some very basic, simple cases, and then there's a more general case, then sometimes it's easier to, instead of putting everything into a single regular expression, just to consider each case individually and then use the plus or the or operator. Okay, so that's what we're going to be doing here. And so in particular, what are the simple cases? Well, that's when the number of A's in W is 0 or is 1, right? Because in each of these cases, it's actually fairly simple to see what the string should look like. So if the number of A's in the string W is 0, and my alphabet is over AB, then that means that the only possible strings that sort of satisfy this constraint are strings that look like just a bunch of B's, right? Because if I have a bunch of B's, then there are no zeros, so there are no A's, so then the number of A's is 0. Now, what about when the number of A's in my string W is exactly 1? Well, that's when, you have your string W and you have exactly 1 A, right? And so to the left and to the right of the A, there could be 0 or more B's, right? So you could have some B's to the left and then some B's to the right. So, for this pattern, it's 0 or more times, right? So that should remind you of B star, right, of the star operator, because that says that the pattern, in this case, the pattern of having the letter B can repeat any number of times, including 0. And for the second sort of constraint, well, that's when, you have B star to the left and to the right of your A's. So that's the conversion from the pattern that we've identified to the regular expression syntax. Okay, so these seem to be the two sort of simple cases, right? Where the number of A's is 0 in my string, then I just have B's, so that's covered by this case. Or when it's exactly 1, so that's covered by this case. Now the more general case, right? So the simple cases, and now the more general case. So the more general case is when the number of A's in the string W is strictly greater than 2, right? So any of these possibilities. So this was the general case. And these were the two sort of simple cases. So when the number of A's in W is strictly greater than 2, well, we can say that we can also sort of write this as it's at least 3, right? So you have to have at least 3 A's in the string W. So what someone might be tempted to do is say, okay, well, I need to find my three A's in my string W. So I need maybe an A here, an A here, and then an A here. And then, you know, I can have B's in between, to the left and to the right. So then I can have some B's here, some B's in between, and then some B's to the right. And then one might conclude, okay, well, that means that the regular expression sort of equivalent is B star A, B star A, B star A, B star, right? So, I mean, this would be a natural conclusion, but this regular expression R actually only denotes strings that have exactly three A's, right? By sort of the same logic as I followed here, right? Because here I have exactly three A's. I don't have any more or any less that can be sort of matched with this pattern, right? And so that's a bit too restrictive because here I'm saying, well, it can be greater or equal to 3. So then, well, I mean, maybe you're thinking, does that mean that I have to sort of hard code every single possible case? Well, then you would get a regular expression that's sort of infinitely long, right? Because you can have an arbitrary number of A's in a string, and so there wouldn't be a cap on the size of the regular expression. So that's not quite what you want to do, right? You don't want to sort of say, okay, well, this is R3, and then do the same thing for R4 and so on, because then that would just create an infinite regular expression, and regular expressions have to be finite. They have to have a finite number of symbols. And so in that case, what you so if you think about this a bit more, then what you can notice is when I say the number of A's has to be greater or equal to 3, then if I look at my string W, it means that I definitely have, you know, at least 3 A's. So I definitely do have this idea of, you know, well, there's my first A, there's my second A, and there's my third A, right? So I definitely need to hard code this because I need to ensure that there's at least 3. But then in between the A's, to the left and to the right of the A's, yes, I can have B's, but I can also have more A's, right? So for instance, here I could have A, B, A, B, A. Here I could have A, B. Here I could have B, A, B, A. And here I could have B, 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 right? So what this is telling me is I can have any string, right? So I can have any string in between and to the left and the right of the A's, right? So here can be any string. Any string, right? Well, if this can be any string, I know what the regular expression for any string over the alphabet AB is, right? I know that this is A plus B star. So then in that case, I'm just going to say, well, I do need to hard code, right? So I do need to hard code the fact that I have at least 3 A's, but then I'm allowing myself to have, you know, any number of A's and B's to the left, in between, and to the right of those 3 hard-coded A's, right? So then here I could have any string, so A plus B star, same thing here, same thing here, and same thing here, right? And so this is the regular expression that covers this case here of the number of A's and W's at least 3. And so then if I put this all together, right, I need to use, because right now I've only looked at the individual regular expressions, but now what I need to do is, because the language L is strings that don't have exactly 2 A's, well, it could be 0 A's, 1 A's, or 3 or more A's, right? And so notice I'm using or. So the natural way of converting an or to a regular expression operator is by using the plus, right? So the final regular expression R will be B star, right? So B star came from here, plus B star A B star. So that came from here. and then plus this regular expression here for the sort of more general case. So I'll copy this and paste it. I'll paste it here. Okay, and so you'll notice that what I was talking about in terms of simple and general cases, that's exactly what happened here. So I have this first part of my regular expression, which covers the sort of simple cases. And then this second part of my regular expression covers the rest, right? So the rest, or the sort of general case. And so another tip is that if it seems like you're only looking at simple cases and you keep adding, so you keep plussing the simple cases, then it might be a problem, because that might mean that your sort of regular expression is growing sort of arbitrarily large, and you might need to find the general case that sort of encompasses those simpler cases, right? So that's kind of what we did here, right? When we were talking about, oh, we could maybe hard code every single case, but then my regular expression would sort of blow up and become infinite. And so that that was covered by this second case here. Okay, and so that's how you create, that's one way of creating a regular expression that describes the language in this question.